Number 11. A crane pulls up a steel beam from the ground at a rate of 4 feet per second. A foreman is on the ground 20 feet from the crane. When the beam is 30 feet above the ground, find the rate at which the distance from the beam to the foreman is changing. All right, it's always a good idea to read it first, so let's see what we can figure out here. Let's draw a picture. So we have a crane pulls a steel beam from the ground. So pretend the crane is over here off to the side, and it has its little angled bar like this, and it comes down and it hooks onto the crane to the beam. There you go. And it's lifting the beam up. So the beam was here on the ground and it's lifting the beam up. So as it lifts the beam up and up and up and up, the beam is, let me put it up here at the top of our crane. There we go. The beam is being pulled up from the ground at a rate of 4 meters per second. So it was on the ground down here. It was here originally, and it's going up at 4 meters per second. Well, that's my y dimension. So I'm going to call that dy over dt, and that is equal to 4. And then it says, at the same time, so a foreman is on the ground 20 feet from the crane. So 20 feet from the crane. We're going to put that right there. So here's our foreman. We'll give him a little hard hat so he's nice and safe. There we go. He's on the ground 20 feet from the crane. So we'll just make that 20. Now it doesn't say he's moving. It doesn't say he's walking towards the crane at a rate. It doesn't say he's running away from it. It just says he's standing there. So a foreman is on the ground 20 feet from the crane. Okay, we got that. It says when the beam is 30 feet above the ground. So when y is equal to 30, the foreman is still standing there. So x is still equal to 20. Find the rate at which the distance from the beam to the foreman is changing. So that is this distance right here. And I'm going to call that z. So dz over dt. Now let's go back and review for a second. I have dy dt, I have y, I have x, I have dz dt that I'm trying to figure out. It gets a question mark. What about dx dt? Well, it doesn't say the foreman's moving. Like I said, he's not going towards the crane. He's not running from the crane. So his rate of change is going to be 0 feet per second because he's not moving. He's just standing there. I don't know z yet. Well, I have enough information. I can figure it out. So let's see what we can do from here. So this looks like a Pythagorean theorem question to me. So we have x squared plus y squared is equal to z squared. And so if I take the derivative, I'll have 2x dx dt plus 2y dy dt is equal to 2z dz dt. There we go. Now let's put in what we know, and what we don't know, we'll just come back and we'll figure that out in a few minutes. So I have this 2 in the front. X I have is 20. Dx dt I have is 0. That's all from down here. So I got all those pieces filled in. All right, let's keep going. We have a 2. Y we're told is 30. Dy dt we're told is 4. All right, we got that. Let's keep going. 2 again. It looks like I don't have z, and dz dt is what I'm trying to solve for. So that's going to stay as my variable. All right, well, I don't have z. How am I going to figure out z? Well, we know a little bit of information. We know that when y is 30, x is 20, because the foreman's not moving. So if we go back to our original equation, x squared plus y squared is equal to z squared. We know x is 20 squared, plus we know y is 30 squared, and we're trying to find z squared. So 20 squared plus 30 squared, that's going to be 400 plus 900 is equal to z squared. 4 and 9 is 1300 equals z squared. So that means that z would be the square root of 1300. I don't need the negative square root because it's a positive distance. It's not in the negative direction. So I don't need to consider the negative. So it looks like the square root of 1300 is what we want for z. So that's going to go right here. All right, plug and chug time. This will go to 0, so that part's figured out. Then if I multiply 2 times 3 is 6, 6 times 4 is 24, put the 0 on the end, is equal to whatever 2 times the square root of 1300 is. And then we still have our dz dt we're solving for. So let's do some division. If we do our 240 divided by 2 times the square root of 1300, type that into the calculator, and I got 3.33 feet per second for my dz dt. So what does that mean? That means that as this beam is being raised into the air by the crane, the distance from the beam to the foreman is changing at a rate of 3.33 feet per second. Let's try the next one. The annual demand of Q for bottles of wine from a vineyard when the bottles are priced at P dollars each satisfies the equation this. The price is currently $14 per bottle. Find the rate at which demand changes with respect to time if the price increases at a rate of $1.20 per year. So what's happening here is they're going to start raising the price for the wine. If they raise it too much too fast, people will stop buying the product. If they just raise it a little bit at a time, they're hoping people will continue to buy. If they made a huge jump and raised to like $10, people would possibly consider getting something else instead. So what's happening here is as the price increases, some people are going to decide they don't want it. They'll buy something else. But what is that rate at which people are choosing to buy something else? And how is that impacting the bottom dollar? When they sell for a higher price, they can make the same amount of money through selling fewer bottles. So where's that sweet spot where they're making more money selling fewer bottles, and not causing their clients to get aggravated? That's what we're trying to figure out here. So let's start with what we know. So we're given our equation. Our equation is QE to the 0.07 is equal to 5,000. How did they write that equation? Don't know. That's what was given to us. We're not given information to see how it was written. But I did notice it's a 3, not a 7. So let me switch that. There we go. That's better. So Q equals E to the 0.03P equals 5,000. Now we're ready to do something. This is a product rule. First, second. So if we go to take the derivative, we need the first times the derivative of the second. Well, the derivative of e to the whatever is e to the whatever times the derivative of our whatever. So the derivative of 0.03p is 0.03, and we need dp dt. Remember, with respect to time. Oops, not equals yet. First times the derivative of the second plus the second, which is e to the 0.03p, times the derivative of the first. Well, the derivative of the first is the derivative of q, so that's dq dt. Remember, the derivative of 5,000, 5,000 is a constant, so that's going to be 0. Now let's see what we can do here. What can we figure out? Well, what information do we know? We know the price is currently $14 per bottle. So that means that I can fill in my 14 for P. So let's start like what we did before. Let's start just filling things in. I don't know Q yet. I know that P, so e to the 0.03 times 14, because P is 14. We're told that right here. I know that we have our 0.03 and our dp dt. Well, that's the rate of change of the price. So that's our $1.20. All right, we've got some filled in there. Let's keep working it across. E to the 0.03, P is 14. And dq dt, the change in demand, that's what we're trying to figure out. Right, so I still need to figure out what to fill in for that Q. So let's go back to our original equation. Our original equation says QE to the 0.03P equals 5,000. So when our P, our price, is 14, what is our Q? So we can substitute back in our 14 for P, which means to figure out Q, we would be looking at 5,000 divided by e to the 0.03 times 14. So if you type that into your calculator, it looks like it should be about 3,285.23. So that's our Q. That is our quantity that we're selling. That is the demand for the bottles of wine when priced at $14. So 3,285.23. There we go. Well, now we can do some plug and chug. Let's put this into the calculator and let's simplify it all down. So if I multiply some of this together, I think all of this will simplify down and we'll be able to solve it for dq dt. So it looks like we will have negative 179.987 divided by e 0.03 times 14 is going to be 0.42, equaling our dq dt. Put that into your calculator, so simplify it down. It looks like approximately negative 118.26 will be our dq dt. So what does that mean? Well, we did a little simplifying here. We simplified all of our part right here, and then we moved it over to the other side of the equal sign, and then we divided right here to isolate our dq dt. So once we did all that algebra and we typed it in, we got negative 118.26. That means the rate of change of the demand is negative 118.26, or in other words, the demand is decreasing by $118 per year when they are raising the price at a rate of $1.20 per bottle per year. So what does this mean? This means that the demand is decreasing by 118 bottles per year when the price is increasing at a rate of $1.20 per year and already at $14. Let's try the next one. Gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? All right, picture over here. So let's see what we can do. Starting it off, the gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute. That's the change in the volume, because it's telling us the gravel is being dumped. You're adding volume to the pile at a rate of 30 feet cubed per minute. So that's the change in the volume. Its coarseness is such that it forms a pile in the shape of a cone. Okay, here's our cone. But we're told the cone's base diameter and height are always equal. So this dimension and this dimension are equal. So our height is equal to our diameter. And if we keep reading, look, it says, how fast is the height? How fast is the height? How fast is the height? That's the rate of change of the height. How fast is the height? That's the rate of change of the height of the pile increasing when the pile is 10 feet high. So the height we're told is 10 feet. All right, let's see what we can do with this. The first thing we need is the volume of a cone. The volume of a cone is 1/3 pi r squared h. You kind of need that one in order to start it off. So what can we do? Well, we know some information here. We know that the radius is half the diameter. And in our case, we know that the radius is half the height because the diameter and the height are the same. So if the diameter and the height are the same and radius is half the diameter, then in this case, radius is also half the height. So we have a little bit of information there. Now, why is that valuable? That's valuable because we have entirely too many equation pieces in our formula. We need to replace some of these so that we don't have as many variables. So because the radius is half the diameter and the diameter and the height are equal in this case, the radius is half the height, and now I can get rid of the r squared because I can put it in terms of h. So that means I'm left with volume is 1/3 pi. 1/2 squared gives me 1/4. H to the third. H squared times h gives us h to the third. Multiply your fractions. So we have 1/12 pi h to the third. Or if you would prefer, you could write that as pi over 12 h to the third. So that's just doing some algebra manipulation on our equation. We haven't done any calculus yet. All we've done is create an equation. Now, why do we need an equation? Well, if I want to figure out the rate of change of the volume, I need an equation for the volume so I can take its derivative so I can find its rate of change. So the rate of change, in order to get that rate of change of volume, I need dv dt, which means I need the derivative. So let's take our derivative. Bring down your power. Subtract 1. Derivative of h with respect to t. Pi is just a constant. It's just a number, 3.14. There's no variable there. There's nothing to take the derivative of in terms of a variable for pi. So we bring down our 3 because that's the exponent of the h, and that becomes 3 pi. And then we subtract 1, so h squared dh dt. Yes, you could simplify the 3 pi over 12. I'm not going to because I'm just going to simplify it down when I solve it out. But yes, you could simplify that right here if you wanted to. So then we need to fill in all of our values. We need to fill in the information that we have so we can finish solving for what we want. Well, what we want in this case is dh dt. So that means I need to fill in h and dv dt. Well, thankfully, I have that information. dv dt we're told is 30. So 3 pi over 12. H we're told is 10. Don't forget to square it. And then we have dh dt. There we go. Do some calculatoring, and it looks like we'll have 30 is equal to 78.54 dh dt. I'm running out of space, so I'm just going to pick it up over here. So if I do 30 divided by 78.54, that will give us dh dt. And doing that division, it looks like we are going to get 0.382 dh dt, and that will be feet per minute. So what does that mean? Well, how fast is the height of the pile increasing when the pile is 10 feet high? Well, it's increasing at a rate of 0.382 feet per minute.